to look at solving what's called the linear system through substitution. What does that mean? Okay, this and this are both technically equations of a line on what's known as like the Cartesian plane. So we have two lines, and as long as the lines aren't parallel to each other, there is always going to be a point of intersection, okay, no matter what we can find. In substitution, the key is in both equations you want to set them equal to something, something similar. So here we'll call this equation 1, we'll call this equation 2. Luckily, we've actually already set the equations equal to something. The first one is set equal to y, and the second one is also set equal to the exact same variable y. So that makes it much easier. Sometimes you'll get an equation where maybe one is set equal to a variable, but there's some other stuff on this side, and you'd have to move it all the way over. You need both of them to be set equal to the same thing. Again, luckily they've already done that. So since they've done that, we can replace the y in the first equation with all of this. All of this can be set in place of y, because this is saying that y is equal to this. I won't even call it equation 3, I'm just going to write it in green here. Negative 2.5x minus 2, okay, I'll put that in brackets so that you can see we've kind of replaced it in equation 1. I'll rename this equation 1. We'll replace that, is equal to 2.5x plus negative 5, okay? Great. Now, I have a lot of brackets here, and a lot of this can be simplified. These brackets on the outside, they're unimportant. We don't need them, so I'm just going to kind of have them disappear here. Yes. And this one here, we have 2.5x plus negative 5. Do you know how we can simplify those two operations? That's right. Yeah. It's just the same as writing subtract negative 5. Okay. So now, the reason we did this is because now we only have one variable in this whole equation. The variable is x. And if there's one variable with one equation, you can isolate for x. So I'm going to put all of the variables with coefficients to one side and all of the constants, those are numbers that aren't attached to variables, on the other side. So let's have, actually I'm going to move the negative 2.5x to the right side. I'm going to try to do this all in one step, so see if you can follow me here. And negative 5 to the other side. And when I say to the other side of something, I mean other side of the equal side. So, help me out here. What would the left side of the equation be if I have all my constants on the left side?
It would be like negative 2 plus 5.
That's right. I'm going to put the plus 5 in blue so we can kind of see that that was our move. And what would the right side of the equation read? This side would be all variables. What's already there? What stayed there?
2.5.
Yep. 2.5x. And what were we removing?
The negative 2.5x.
Yeah.
Would become 2.5x.
Yes, positive 2.5x. Perfect. Okay, good. So now we have like terms. Negative 2 and 5 is going to give us 3. And 2.5x plus 2.5x is going to be 5x. Perfect. The goal here is to get x by itself. Okay. Now technically this is 5 times x. So to move that 5, we'd have to use division. And you could leave this as a fraction. In fact, you could say x is equal to 3 over 5. And you could be done. Or you can make it a decimal. 0.6 would be the decimal here. Okay? We're not done. When you're finding a linear relation or a system of linear equations here, this is just a rough sketch. You're finding some coordinate, and that coordinate has both an x and a y value. We just found an x value. It is either 3 over 5 or 0.6, whether you use fractions or decimal. We're still left solving for the y. Okay. So now that we have that, we can take this value and plug it in for the x in either equation 1 or equation 2. It doesn't make any difference at all. I think I'm going to work with equation 1 because it's got a positive coefficient. It really isn't much simpler to multiply, but we're going to go with that. Okay? So I'm going to bring equation 1 down to the bottom, positive 2.5 minus 5. So here's equation 1 again. And it read y was equal to 2.5x minus 5. And our x value was 3 over 5, or 0.6. Since this is a decimal, probably best to work with decimals, but you know what? I'm okay with math. I'm all right at it. 2 over 1, 2.5 over 5 over 2. 5 over 2x minus 5. We'll call this our fraction side and this our decimal side. We'll solve it both ways. Okay. So on this side, y is equal to 2.5. And like I said, we're going to replace x with our decimal value here. So 2.5 times 0.6 minus 5. And again, we're still isolating for y. Y has just already been put to the one side, and all we left is constants on the other. And with our fractions, we have y is equal to 5 over 2 times, actually, I guess I should have used the colors I used above, 3 over 5 minus 5. Wonderful. Okay, y is equal to, let's see if I can do this quickly, 0, 3, 15, so 1.5. We'll get a calculator to verify that in a minute or two. I'm going to say that's 1.5 minus 5. And in our fraction version, this should be 15 over 10. And if you were to divide 15 by 10, you would get 1.5. So I'm actually on the right track. That worked out great. And finally, 1.5 minus 5 is going to give us negative 3.5, I believe. Here, we would turn this into a fraction. Technically, it's over 1. To make the denominator the same, it'd be 50 over 10. And y is equal to negative 35 over 10. And again, if you were to divide that, you would get that value. So our coordinate in the end would either be 0.6, negative 3.5. There's your x and there's your y. Or 3 over 5, I think it was. And negative 35 over 10. And then you could reduce this. You could divide it by 5, and I think you get 7 over 2. Is that right?
Yeah.
Yeah, that's right. Negative 7 over 2 would be the other option. So let's verify our answer. A lot of steps, mainly because it was a decimal question. These actually wasn't that difficult, and we decided to do both decimals and fractions when we solved. But if we put this into decimals, let's confirm our answer here. 2.5, sorry, y equals 2.5x minus 5. Y equals negative 2.5x, what was it? Negative 2. All right, so our point of intersection, 0.6 and negative 3.5. Perfect. Worked out great for us. So let's